And we're going to be talking about objectionable current. We're going to be talking about the effects of it, but also we're going to be looking at an illustration that was posted on social media that caused quite a bit of a buzz because people were making comments about something you could simply do to resolve the issue. And it was over on TikTok mainly. And again, it sometimes scares me, the level of commenting that people make on images, especially if they don't understand the National Electrical Code. So to that effort, we're going to try to clear this one up for everybody and kind of give you some insight into the problems with objectionable current, how you create objectionable current, how you mitigate the issue in the example that we're going to show. But more importantly, I think it's important to show what happens when you do an improper case to neutral connection on the load side of a service disconnecting means, like at a feeder panel, a feeder type load center, a remote distribution panel downstream. Let's say you have your panel in your garage and you have a basement and you're going to want to install a panel in your basement. Okay, you run 4 conductors to that, you isolate the neutral bus and you connect the equipment grounds to the enclosure, but you ran a separate equipment ground, 4 conductors, in order to make sure that you don't put neutral current on those metal parts. Now, we've been doing this now for quite a few cycles, and it's created a much safer environment so that we don't have what's called a case to neutral connection. So what is that case to neutral connection? That is where you improperly connect the neutral to the metal enclosure downstream from your service disconnect. You do this in your service, but you do not do this downstream of the service because then it creates circulating currents, and that is known as objectionable current. It can affect electronic devices, very sensitive electronics. We don't want to risk it having any issue with anything that we may have in the house that could be sensitive and could be things like safety devices. We don't want that to have the possibility of interference, but probably more importantly, we don't want to create a condition where we're intentionally putting current onto metal parts like the enclosure, like the wiring method, if it's a metallic type of wiring method. We don't want to put current on that product in order to create what's called a touch potential issue. And that creates an issue. Not to mention, if we happen to lose the neutral and you improperly make that connection for the neutral to the enclosure downstream, if you lose the neutral, now you've got current traveling on the metal parts. And they weren't evaluated to be considered current carrying components. So they can handle fault current, and that's what an equipment grounding conductor does. It's for fault current, but in clearing an overcurrent device, that's the primary function, although it does tie metal parts together and serve a bonding role as well. We find all that in 250.4 of the National Electrical Code. Reading all that, it's a great read. But when we do that improper case to neutral connection, we create a hazard. And so we want to look at the illustration, and I'm going to point out in this illustration how we can solve this issue, but I do want to bring up things that people were so quick to comment that they didn't really look and see everything in front of them because they couldn't see the forest for the trees. So let's kind of go look at it real quick. All right, so here's the illustration that we were talking about. So here you have your service conductors coming in. All right, and here's your main service disconnect. Here's your grounded neutral conductor coming from the utility. Okay, it's coming in, and you see this bus. Now, just to let you know, see this conductor right here? This is a main bonding jumper. You could have just put a green screw in here and called it a day, but there's a lot of reasons why we separate these in our illustrations in our grounding and bonding course. It's because we want to take the opportunity at certain times to size this main bonding jumper if it's of the wire type. So we break it out so that we can teach you a lesson in sizing. Again, at the end of the day, it might be just a green screw right here in this neutral bus, and that comes from the manufacturer. You do nothing. But we take every opportunity we can to try to break things out so that we can teach lessons on it. And that's what our grounding and bonding course over at fasttracksystem.com is all about. It's tackling all of those tough issues to teach you grounding and bonding, because I believe everybody needs to have a foundation in grounding and bonding, okay? All right, so let's look at this right here. So this is the illustration that we posed. So here's your main breaker, here's your feeder breaker, and this is a feeder, and it's coming down in this remote distribution panel, this feeder load center, however your flavor. And the one thing you'll notice is that it only ran 3 conductors. And so here the neutral is got a green screw and it's bonding it to the enclosure. This is where we're talking about an improper case to neutral connection downstream of the service equipment. This is prohibited. Not only does it create objectionable currents, meaning, as we talked about earlier, here you see if there is any neutral current traveling back to the source, it's going to travel back on the neutral, but it's also some is going to be traveling back on the metal parts. Now, it's all proportional to the impedance of that path. So obviously more current's going to travel on the white conductor than the metal enclosure. But when it comes to touch potential, if you have a poor connection for that neutral, then more current's going to travel on the metal parts and it creates that touch potential. And we're not supposed to be intentionally putting current on the metal parts. So some people say, so this is a violation. Now, what does this violate? What code rule does this violate? Objectionable current, obviously 250.6. We're creating objectionable currents. We're creating issues as a result of objectionable currents, which can cause problems with sensitive electronic equipment. But we also have to go to the NEC in 250.24 and look at 24B right here. Load side grounding connections. Now, in the 2023, it's got moved to B. If you're in the 2020 or earlier, it's 250.24A5. So it just had a little bit of a move, but it's still the same information. And it says, a grounded conductor shall not be connected to normally non-current carrying metal parts of equipment or to equipment grounded conductors or be reconnected to ground on the load side of a service disconnecting means. So that is the general premise to the rule, right? So in our case, this is what's taking place. So some people say, well, Paul, just remove this screw. And now this bus is isolated. Well, first of all, we don't know that it's isolated because it could be screwed straight to the metal enclosure, even though they did put the green screw in there. So it needs to be floating, not in contact with the metal, okay? And you see this bus over here, which does have the green screw. This is fine because that connects this bus to this enclosure. And ideally, we'd have, if this was MC cable, for example, then we would have an equipment ground run with it, running over here to here, and then we would be done, and we would isolate this neutral by taking this green screw out, and we'd be done. Now, some people say, well, Paul, why don't we just use the raceway here? Or this case, it says metal cable. That's all we need to do because 250.118 says that I can. Well, yes, 250.118 does say, and it gives you a list of things that are allowed to be used as an equipment ground. But because the conductors in here are probably larger than 20 amp protection, means the overcurrent device is larger than 20, because it looks like this is a feeder panel downstream. Let's say probably 100 amp rated. So that case, you're not going to be using liquid tight flexible conduit. You're not going to use flexible metal conduit because they have limitations on the amps, and that would be a problem. So that's not going to be used. This is not MC cable because I see no separate equipment grounding conductor, and you can't use the MC armor as an equipment ground in larger sizes. You can in specially made MC with 6-gauge conductors and less, but that's not what this is. Okay, so all of this is listed in 250.118. I encourage you to pause the video, go look at it, and see the different allowances. Now, if this was rigid metal, intermediate metal, if this was EMT, all of those type of raceways and tubings are listed over in 250.118. But this is not. This is not an MC. This is not an AC cable because typically AC cables wouldn't be in larger than 1 gauge, so we would limit the size, okay? But it may be an AC cable if this was a smaller size remote distribution panel. But what we wanted to point out with this illustration was that if you just remove the screw, it doesn't remove the issue because now we still have to make sure that that return path for the fault current is either a raceway or a cable that is allowed to be used as an equipment grounded conductor. And as we said, this is obviously not MC cable. This is obviously not AC cable. The other types are limited by the overcurrent protected device protecting the conductors in the cable, usually to 20 amps or less. So in this scenario, you have a problem. Okay? Now, let's go on and look at 250.118 so that we can see the different types of wiring methods that maybe would qualify as an equipment grounding conductor, and we try to make this installation right, okay? So let's go see what the code says. All right, over here at the code, let's go to 250.118. That's the different types of equipment grounding conductors. All right, so they didn't run a conductor in there. Okay, so that's an issue. Now, maybe they have the ability to put this conductor in there. Okay, we'll see. But it's not going to be in some of these cable methods. It's not going to work. So let's see what we've got. All right, no conductors run, so we don't have an equipment ground. If it was rigid metal conduit, we're good. Then you could just simply remove that green screw in the neutral, and you'd be good to go. Intermediate metal conduit, it would be good if it was that, but it's not. EMT would be fine between that service panel and that remote distribution system or that load center or that feeder panel. EMT would be fine. Now, could I use flexible metal conduit, FMC? Well, you could, but you have some limiting factors. You have some size limitation, okay? It does not exceed trade size 1 1/4, but also the conductors that are inside of that FMC, okay, have to be protected by an overcurrent device rated 20 amps or less, okay? Well, in that scenario, that's not going to happen. So, it couldn't be FMC that would work. Next, let's go down and say, well, what about liquid tight flexible metal conduit? LFMC. All right, well, you still have the same restrictions here, okay? It's for 3/8 through half, then it'd be 20 amps or less. Then it would be, okay, well, then you have 3/4 through 1 1/4, then you have a not more than 60 amps, okay? So maybe this is LF, liquid tight flexible metal conduit. Maybe this is only a 60 amp feeder panel. Okay, maybe. But those are the things that we want to discuss. And that's what I was trying to get people to pull all this stuff out in the comments rather than me just give them the answer right away. I always want my posts on social media to be a bit of a learning experience and get comments. Everybody immediately just wants me to give them the answer. I like conversation, but remember, I delete stupid stuff. If you really have a genuine question, then we let those through. But we're not going to let people go down a rabbit hole and take our social media stuff downhill with them. We're not going to let it. This is a learning environment, okay? All right, so let's go back to the code here. So anyway, there you go. And of course, there are length limitations as well that you have to be aware of when it comes to liquid tight flexible metal conduit. Now, what about flexible metal tubing? All right, well, can't really say that we can use this because, again, that's limited to conductors that are protected by 20 amps or less overcurrent device, so that's not going to really play a role in our example. AC cable typically is not something that you use. It is limited in size, although you can, if you can find larger AC cable, typically goes up to 1 gauge. Well, if you find it, then you can use it, that type of scenario. And let's see here. MI cable, no, not going to happen. MC cable, typically standard MC cable, again, comes with an equipment ground inside of it. And that would be okay if that was included, but in our picture, it wasn't there. Then people say, but don't they make an MC cable where the armor can actually be used as an equipment ground? And they do, just not with conductors inside of it larger than 6 gauge. Okay, so 6 gauge is that limitation on that type of product. And other examples we see of that is like the smart ground products for Encore wire or the MCAP for a south wire. Those products tend to have conductors inside of it that are 6 gauge and smaller. Okay, so typically not going to see it there. Okay. All right. What else? Okay, so cable tray, that's obviously not what's in our drawing. And of course, cable tray has to meet these requirements as well, has to be listed for use in grounding and bonding applications for those cable trays. They're out there. You just have to find them, but we don't have a cable tray in this image. And we certainly don't have a cable bus. We don't have anything like auxiliary gutters and things like that. And we're not talking about surface metal raceways. Okay, so absolutely not in this scenario. So right here, whether we can just remove this screw or not and make this compliant really gets into a deeper discussion on what type of wiring method we're using. And in this illustration right here, it's evident this is not going to be MC cable. And it's evident that this overcurrent device, whether you want to argue that or not, it's evident that we're not going to feed a panel like this with a 20 amp circuit. Now, could this be liquid tight flexible metal conduit and this be a 60 amp remote panel? Maybe. And if that's the case, okay, if you meet all those link limitations and follow those rules, then maybe you can get away from that. But other than that, you're going to be very limited in the application. Okay? So that was the whole purpose of the illustration, was not just to talk about the objectionable current, not just to talk about the improper case to neutral, but also what are your recommendations for fixing it? Well, in this case, you could remove this and put an MC cable in there with a properly sized equipment grounding conductor based on the size of the overcurrent protected device. Although UL 1569 already sizes the equipment grounds standardized for whatever the amps are of those conductors and whatever anticipated breaker they would be terminated. So you really don't control that with an MC cable. Although you can order MC cable with an oversized equipment ground and things like that if you want. It's just going to be a lot of lead time and probably going to cost you more. So off the shelf MC, the equipment ground's already going to be sized for you. All right, so important. So you do have some options. I encourage you, if you want to fix this situation, go and look at 250.118 and see if the wiring method that you're using, okay, actually qualifies as an equipment grounding conductor. If it does, then you do remove this screw, isolate this neutral bus, all right, and then you're all good to go. And then you would be okay. So that's the whole purpose of that illustration. And I do this a lot, folks. So I encourage you to follow me on my social media platforms, whether it's TikTok, whether it's Twitter, whether it is YouTube. All of them are at Master the NEC. So I encourage you to follow them because I don't always post the same content on every platform. So hopefully you got something out of it. And lastly, a lot of these videos will be exclusive over on Fast Trax Tube. I encourage you to go check out Fast Trax Tube. Here's a discount coupon right here so that you can get, what, 50% off your annual subscription to Fast Trax Tube. All right? All right, folks, I appreciate you. Thanks for watching, and hopefully you got something out of today's video. We'll catch you in future